Okay. All right. I said we've started this before, so I'm just going to refresh it again. So under this second application of dimensional analysis, we've looked at the first application, which is to show whether equations are dimensionally correct or they are not. Okay. And now this second application of dimensional analysis is to derive the equation connecting physical quantities. We will be given information concerning the dependence. Okay, like this question says now that the period symbolized as capital letter T of oscillation of a simple pendulum depends on length, okay, and then the gravitational acceleration or acceleration due to gravity. We are now told to determine the exact equation connecting these physical quantities. Equation connecting T, which is the period, connecting it to L. It is T that depends on this. This is the dependent variable. You know, if you have y equals to whatever x squared, quadratic equation plus 2x plus whatever, this is the dependent uh, um, index here, and this x is the independent. So, okay, y needs a value for x. If we have y equals to 2x plus 5, okay, this y depends on x, so we call this the dependent variable, this the independent. We have to give a value for x. For example, if y x equals to 1, so this equation is going to be 2x means 2 times 1, 2 times 1 plus 5. What is 2 times 1? 2 plus 5, 7. So y is going to be 7 when x equals to 1. If you give x another value, 3, y, that is when y is not going to have value. So y depend on x. So here we say x, the period of oscillation of a simple pendulum depends on two parameters, and they are the length of the simple pendulum and acceleration due to gravity. So at first, we just have to write the dependence. Y T equals to L, which is the dependence here, length, and then G, which is the gravitational acceleration here. When writing them, we must give them power. Use any other letter apart from T, L, and G. So I'm using X and Y. If it depends on three things, T depends on L, G, and V. I'm going to give them X, Y, Z powers, or A, B, C, or M, N, different letters different from this. Okay, the next thing now is we are familiar with the dimension. We are going to write this L and G in terms of their dimensions. The dimension for length, this L is capital letter L. Okay, the dimension for G of acceleration, well, is gravitational acceleration. I mentioned earlier that whether any type of acceleration, it is acceleration. Okay, whether linear acceleration, angular acceleration, gravitational acceleration, it is acceleration. Okay, so the dimension is always the same. So let us write this now in an equation form. T, we remove this proportionality sign by introducing equality equals to a constant, then length raised to the power x, gravitational acceleration raised to power y, such as we have y is proportional to x. You know, we are going to write like this: y equals to constant, then before x. We cannot solve this because it has no equality, but we can solve and manipulate this. Now, this is now what is the dimension for length? We're going to write it in terms of this equation. So I'm going to write it t equals to the constant, and this length has the dimension of capital letter L. That's the dimension for length. So that is going to have power x. And then what is gravitational acceleration? The velocity, the dimension for velocity is L all over t, or LT to the power minus 1. And that for acceleration is L divided by t squared. Indices says we can write it like this: L, this t will come up, the power 2 was positive before it comes to minus 2. So I'm going to be using the second format. This is acceleration, G is acceleration, right? So open the bracket there. G is LT to the power minus 2. L T to the power negative 2. I close the bracket. This LT to the power minus 2 is representing G, acceleration. But everything has power y outside, so I'm going to put power y outside here. Okay, now we introduce in initial rules in our last class. We said if you have xy, okay, everything raised to the power m. You are going to give the two constituents inside the bracket. This power is going to be first x to the power m and then y to the power same m. Okay, so now I'm going to write this. Let me leave this t. This is going to be k l to the power x. Now this l is within this bracket. It's going to have that power y outside. So it's going to be l to the power y. Then there is t here. T as power. We looked at a rule as well. This rule that if you have x having a power to the power y, then there's another power n outside. The result is going to be x to the power y times n. It's going to be yn. Y multiplied by n, yn. So this is going to be, where is it? It's going to be t to the power, it has minus 2 inside, then y outside, going to be minus 2 times y, minus 2y. Now we are good to go now. This is now the manipulation. Remember, the of indices that we can use to combine these two L and L with their powers combined. Okay, so let's quickly do that now. This is equals to K, because it is L multiply L to the power y multiplied by another L to the power y. It's going to be L to the power, we'll add the two together, x plus y, x plus y. This is indices. Then I have t to the power minus 2y. We are getting there. Remember, what is ordinary here is t. The period t depends on gravitational acceleration and then the length of the pendulum. Now, what are the two parameters we have on the right? I have length and I have time. I have length and I have time. I told you earlier that you should remember there are 7 fundamental quantities that we looked at. We are going to be familiar and be using more, 3 of them. What are those 3? Mass, length, and time. I told you that the dimension for mass is capital letter M. The dimension for length, as we saw, we changed L to capital letter L. And the dimension for time is capital letter T. So just memorize these 3. Mass, length, and time have the dimension capital L, capital M, capital T. Okay, so on this left-hand side that we have only T standing alone, that T is standing alone here, we're going to include M, L, and T. But the one that does not exist actually here, which is M, there is L here, I can see L, and I can see T. The one that does not exist, which is M, that I want to write, give it power 0. When something has power 0, it is something as 1. M to the power 0, just write it here, MLT. I want to write them, M to the power 0, L. Does L exist here ordinarily? There is no L here. So I'm the one including it. I'll give it also power 0. T is the only thing represented here. I leave the T. Those M, L that have power 0 means they are just 1. M to the power 0 is 1. L to the power 0 is also 1. So it's like I'm just writing T. If I write A, B, C, D, E, F, G, and G is only 1, having power 2, then all those one, M, L that I wrote before, I'll give power 0, 0, 0. It's like they are not there. So they are really not there. So I'm writing like this. There's a reason why we need to write it like this. Equals to K, L to the power X plus Y, and then T to the power minus 2Y. Okay, now the next thing we are going to do is we are going to be comparing the exponents of all the parameters on the left and on the right. Now, do we have M here at all? There is no M. Let me just ignore M. Now, what's the next thing we have? L. This is for L. I want to compare for L. Let me put this like this. I want to compare for L. Okay, dash, dash. Now, what is the power of L on the left-hand side here? The power of L on this side is 0. So write 0. Then what is the next thing you see here? Equality sign equals to, what is the power of L on this right hand side? It is X plus Y. Just write it down. X plus Y. I can leave it. I cannot solve anything here. I just leave it at maybe equation 1 like that. Okay, equation 1. Let's go. Now T. I want to see T. I want to compare T. Let me see. I'm comparing T now. That's why I'm putting like this. I want to compare T. What's the power of T on the left? T is the only thing existing here. Since there's nothing written here, it means it is 1. So I'm going to write 1. I'm writing what is on their power. Then equals to, go to the T side. What is the power of T on the right hand side? Minus 2y. minus 2y. Yes, this is equation 2. It is from equation 2 I can solve something. You can see for equation 1 I have two letters x and y, and then a number 0 on the left hand side. But here I have just one letter. 1 equals to, I can solve for y here and then go and substitute in equation 2. This is just like simultaneous equation. So from equation 2, from this equation 2, I want to write a letter on the left. I can already write it like this: minus 2y equals to 1. How do I now find y? Divide both sides by the number standing in front of that y. This is minus 2. Divide this on 2 by minus 2. That's how we solve equation. So minus 2 gets away minus 2. I have y left. So y equals to 1 divided by 2. I've gotten for y. Y equals to 1 over 2. Then from equation 1, 0 equals to x plus y. I can write it like this. Write x plus y first. X plus y equals to 0 is the same thing. Now, what is the value of y here? Y is half. I can write it here. X plus half, x plus 1 divided by 2 equals to 0. From here, I can take this positive half to the next set. So it's going to be x equals to 0 minus 1 over 2 is going to be minus 1 all over 2. Now, I've gotten the two values for the two powers I introduced. X equals to minus half, x equals to minus 1 divided by 2, and then is that a challenge? Let me confirm. Yes. Yes, of course. For one of them, x equals to minus 1 over 2, but y equals to 1 over 2. One is one. Look at this. Y is equals to 1. Oh, sorry. Thank you very much. Y, thank you. You are following. This is y is the one that's having minus. Thank you. Y is equals to, this is 1 over minus 2 means minus 1 over 2. If you have something, thank you very much. Who notified me that? If you have something like this, if you have minus a divided by b, is the same thing as putting the minus at the denominator. It's the same thing as having a all over minus b. And it is same thing as just putting the minus in their middle. Minus a divided by b. Minus should just be there. So there's minus in the denominator here. That's why I put it like this now. Y equals to minus half. So let me go and rewrite this. Thank you very much, that person. Thank you. So y equals to, this place now is not going to be positive again because y is going to, let me write it. Let me clean it. Let me clean all this part now. I want to substitute. Y is actually minus 1 over 2, not 2. Okay, so this is going to be x. The plus is going to affect, let me write it, plus, open bracket, since y is minus half, minus 1 all over 2. So everything is equals to 0, right? Equals to 0. Now, this plus and minus will interfere and everything will still be minus back. So x plus times minus, minus 1 all over 2 equals to 0. Now, take the minus half to the other side. So x equals to positive 1 over 2. Thank you very much. So it is x that is positive, y is negative. Let me clean this one back. Let me clean this one. So x is x equals to 1 all over 2. And then y equals to minus 1 all over 2. I hope everybody is saying. Thank you very much, that person again. Okay, so let's go ahead now. We want to go and substitute this power x and power y into the original equation. What is the original equation that we have? Let's go. In working this, let me just tell you, because I also mark y, although I've stopped. Okay, these are the stages they are marking, not all these your indices. These are the stages they are marking. Did you write this dependence? T is proportional to L to the power x, G to the power y. They'll mark this for you. Then the next stage you write is introducing constant. Did you write this? You get marks. Total mark may be 3 or 5. So they will split it. Maybe one will be half. For writing that one is half. For writing the next one is half. They check your working. Maybe that one will be 1. And final answer, maybe you are correct. That one can be 1. So they'll mark that for you. And then after this, introduce equality. So this is the one that we'll now need. Now let me put it inside box. I'm going to copy this and then substitute the value of x and y back. Okay, now let's go. Let me write t equals to k l to the power x g to the power y. I'm going to write that back now. So t equals to a constant and then L to the power X and then G to the power Y. So this is equals to K. Okay, what is L? This is L. Now what is the value of X? X is 1 all over 2. 1 divided by 2. And then G. What is G? Raised to the power Y. Y is minus the same value, but 1 is minus 1 all over 2. Now indices will work here now. Indices again. Let me write this now. Indices comes in. So T equals to, are you familiar with how if you have x raised to power 1 all over 2, the meaning is square root of x. That is just the meaning. So instead of saying square root of 4, it's same thing as square root of 4, square root of 4, which you know the answer to be 2. Square root of 4, which you know the answer to be 2, can be written like this: 4 raised to the power 1 all over 2 and divided by 2. Anything raised to the power half means square root. Square root, okay? So this means square root of L, t equals to constant k, and then square root of L. You can see that. What can you see again? Let's before this, let me introduce this. Let's do this indices. Let's do this indices. You have known that square root means square power half means square root, right? So this is going to be L to the power 1 all over 2. I'm coming. Times, this is, hello, wa alaikum salam. Okay, from what stage then? No, this no, it's only that's why I introduced from beginning. Indices. Okay, okay, okay. Okay, please speak. Let me know from where, and then I'm going to. So I know the indices is the challenge here now. Not the, okay. Please speak. You click on that. Okay, no, I think if she's shy to speak, I think I've understood a challenge. The thing is, this topic needs indices. Those that follow this class from the beginning, I said there is a part of indices that I intentionally introduced before starting the topic because I know it's a requirement to learn this topic. This topic is dimensional analysis. You need indices to understand it. And before taking this topic, from the beginning on the first day, I will look at in the rules of indices. Now, this aspect of we are looking now, we didn't look at it before, but I think it's part of what you maybe you have understanding of in maths already. But let's does anyone have challenge here too of this aspect of these indices? Does anyone have challenge? Please speak. No one with dimensional analysis. Okay, let me go over this again. Let me scroll up. Let me scroll up. Don't worry. I'll scroll up now. In fact, we even use variation as well. Whoever that noticed. Okay, it's because it didn't follow from the beginning. I said we have looked at the dimension of some physical quantities earlier, and then when we get to application of dimension analysis, we introduce two applications. One of the applications of dimension analysis is to show whether equations are dimensionally correct. I'm going to, if you can please, if you see the number, my phone number is the one on the WhatsApp group, is one that, although I'm going to send that video, maybe if you have data, you should download it. You should download it and then watch. I'll try to see what we can do to further minimize it. So I can download and watch the beginning part. Okay. This second aspect of dimensional analysis is dimension. But fake divide. Okay. you need to watch the beginning because yes, yes. The short, yes. Yeah, the short explanation I will still give now will still not help. So you are going to watch the video. Then if there's still challenge, and then you can come to my you can ask me question anytime. The first thing is just to know how to write this. We are going to look at another example, which you are going to see. The question, write may frame it in different way. This one is saying the period. You can period is letter T in physics, okay, and period is measured in seconds. Anything that can be measured in seconds is representing time. So, what is the dimension for time? Capital letter T. Oh, I need to mention something again. There are symbols for some for some quantities. Velocity we usually use V. If it is initial velocity U, final velocity V. Okay, frequency is F, acceleration is A. Period has a symbol of capital letter T. Okay, and then fortunately the dimension of that period T is also T. So you can be confusing this T from this stage here. The T I introduced at the beginning again. Okay, T is small for period. Okay, but from this third line here that I'm taking here, this T here is dimension for period. It is just unfortunate that the symbol representing period is also capital letter T, which is the dimension for time. Just like the symbol for length is small letter L, but the dimension is capital letter L. The symbol for mass, a body of mass, you see small letter M, but the dimension for mass is capital letter M. Okay, the symbol for force, we usually use F, depending on the nature of the force. If it is tensions, they are all forces. Anything that can be measured in Newton is force. It must have the same dimension as force. So force is usually F. But when we write the dimension, because it's a derived quantity now, it combines so many letters. You see M, L, and T. You are going to watch that video to see. So here, do not confuse now. The T you are saying at the beginning here is symbol for period. This T you are saying at this second stage is still symbol for period. You can see L here, you can see G here. But from the third line, this T is dimension. It's just fortunate that they both have the same representation now. T is what we use in representing period, and the dimension for time is also capital letter T. We can know the dimension of physical quantity if you know the unit. If you don't know the definition of a quantity, but you know the unit, period is measured in seconds. Anything that can be measured in seconds must have the dimension for time, because time is fundamentally measured in seconds. So if period is measured in seconds, its dimension will look like the dimension of time, which is capital letter T. T, we are saying here, is actually the dimension for time. But because period is also measured in seconds, which is the unit of time, that's why it's also having the dimension for time. So T above is the symbol for period. Then the T from the third line is the dimension for the period, which is dimension for time. Okay, please, you are going to watch that. And then since you say you don't have challenges with indices, please, let's just keep going. Now, we remember as well that if we have maybe x to the negative power, if it is, even though the power is fraction, minus a divided by b is going to be 1 divided by then x. What was the power before? Minus a over b is now going to be positive a over b, positive a divided by b. So that's the same thing that I want to do here now. I'm going to write this g raised to power negative 1 all over 2. I'm going to write it as 1 divided by g to the power positive 1 all over 2. Now I can now introduce the square root. Okay, this is now t equals to a constant. Then L to the power half means square root of length. multiplied by 1 divided by the square root of gravitational acceleration. Now I can combine these two. 1 times square root of L is the same thing as just square root of L divided by, this is like over 1 again. 1 multiplied by anything gives itself. Now under surd, this aspect combines so many aspects. Under surd, you have square root of A multiplied by square root of another separate quantity or any number B. You can combine both of them under a single square root and say A multiplied by B, which is something as square root of AB. Okay, and if it is division 2, square root of A divided by square root of B. You can combine them on a single long square root of A divided by B. So I'm going to do that here. This is period equals to constant. You can see square root above, square root below, a single square root L divided by G. You will notice that you are familiar with this equation for period. This constant, which calculus can find, we are not interested in that. It's going to give you 2 pi. You're familiar with formula KT equals to 2 pi root L all over G. So this is the equation they are asking us to find. Under this aspect, you leave the scale like that. Don't change it to 2 pi because you are aware that the value of the constant is 2 pi. This T equals K L over G. This is the final answer. This is the final answer. Let's see another problem. Maybe persons that have challenges with this may get it this time, although there shouldn't be a problem with this. Now, assuming I'm going to ignore because of time, let me ignore typing this. Let me just tell you and then write the equation down. Equation saying that assuming that the distance covered by a particle, symbol distance is L, assuming that the distance, I want to symbolize it as S. The distance covered by a particle, I'm supposed to type this, okay, because of time, because I want us to look at another one that has square root again. Where, sorry, if we look at another one, assuming that the distance covered by a particle, this distance is symbolized as S, depends particle starting from rest. Okay, the equation is going to say the particle is starting from rest. Assuming that the distance covered by a particle S, which is symbolized as S, starting from rest, depends on acceleration. So S depends, let me use the symbol, S depends on acceleration, not only acceleration, okay, symbolized, which is symbolized as A, and then time T, depends on time T, for which the journey elapsed. Again, assuming that the distance is S, covered by a particle starting from rest, depends on acceleration A and time T, for which the journey elapsed. Determine the exact equation of dependence. We are told that S depends on A and T. S is distance. Distance covered by a particle which starts its journey from rest depends on the acceleration of the particle and the time for which the particle journeyed. Now we want to derive the exact equation connecting S to A and to T. The equation connecting S to A, you have told which one depends on the other. When you are told that A depends on BC, just go and write that variation proportionality. S depends, which is depends on A and T. The distance, this is the S, distance, covered by a particle that starts its journey from rest, depends on the acceleration of the particle and then the time elapsed throughout the journey. If you spend 10 seconds, it depends on the time. Yes, your journey, the distance you cover depends on what time did you cover it as well. And then how fast, what is your acceleration? You have very slow acceleration, you may cover more time. You spend more time to cover that distance. If you increase your acceleration, okay, you will use lower time. So it depends on both. The more the acceleration, the lesser the time. Okay, when you see something like this, let me just give you a hint. Okay, you see multiplication sign shows inverse. One is bigger, the other is going to be small. So let's write the variation again. Let's after this, what are you going to do? S equals to a constant, yes, a constant. Then you can now write your acceleration and then time. but something is mixing. I want to use different letters now. Power m, power n. The power is not clear. Okay, this is acceleration. I must give it a power, a letter different from the one I'm seeing. Then time also power n. I can use a, b, I can use x, y, m, n. Okay, now the next thing is they will mark this for you for writing this. They'll mark this for you. You see, the rest thing you are going to be doing, they will during marking, they will just overlook it and they just round up a mark for you at the end. Then final answer. Did you get the exact dependence after finding this? After finding this m and n, okay, then the next thing is now what is distance? What is the unit of distance? Distance of 200 meters, 300 kilometers, 2 centimeters. Your ruler, if distance is very, very short, you can use ruler to measure it. Distance from the page of your paper, the top to to maybe the midpoint, a ruler can measure it, and that is going to be in centimeter. If it is very, 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 very small, it's going to be in millimeter. Just like you want to measure the thickness of bring out that tube of your pen, then you want to measure the diameter, although there's it's going to be in millimeter because it's very, very small. But the longer the length, you want to measure the distance from the distance from your desk, okay, from one part of your desk to about the middle of your desk in your classroom. You cannot use ruler again unless you want to use the ruler like multiple times. Okay, you use the ruler just 5 centimeter, then you mark it, and then instead of that you go to use a meter rule. The bigger the distance, the more the unit you are going to be using. The distance is now from your room, okay, to your kitchen. Why are you measuring it in centimeter? Which ruler can measure? Why not use meters? Because a full length of meter rule is just 1 meter. 100 centimeter makes just 1 meter. So 2 meter rules means 2 meters. So if you are saying 200 meters, it means 1 meter rule in 200 places. It does not make sense to use ruler again for that. And it does not make sense to be calling it centimeter again. Since that is long, it is not going to be a meter. If it's not very, very wide again, from Lagos to Kaduna, it will be measured in kilometers. You understand now? So this S, they said distance. Anything that can now be measured in meter, centimeter, millimeter, kilometer, that thing is actually length. It's actually length. So if you don't know the dimension for a physical quantity, but you know the unit, if it relates to anything that you know, if something you don't know the name, but they put the unit to be kilogram. What is usually measured in kilogram? Mass. What is the dimension for mass? Capital letter M. So we have seen that distance is measured in the unit of length. Automatically, it has the dimension for length. So let us write the dimension for S is going to be capital letter L. Dimension for length is L. So distance is actually L. Distance. It's actually length. Height is length. Okay. Breadth of a rectangle is length because they put a rectangle. The length is 2 centimeter. The breadth is 1 centimeter. The height is this centimeter. The thickness of this is something centimeter. The wideness of this, the radius of a circle, the diameter of a circle, they put it centimeter, it is actually length. So the dimension is going to be capital L. Now equals to K. We have mentioned this before, and if that lady, that girl watches the video, you see that the dimension for, I always say it, just remember, I memorized like that in secondary school until I was not familiar with it every time. Velocity has the dimension of L over T. I always write, maybe if I write it most time, you always memorize it then, or L, then this T to the power 1, when it goes up, becomes T to the power minus 1. Anytime you change this to T to the power minus 2, it becomes the dimension for acceleration. Okay, so this acceleration here is LT to the power minus 2, but it has a power. So let me open a bracket. L, so it's capital L, then T to the power minus 2. Okay, close that bracket and give it the power it has before, M. And then what is this? Time. What's the dimension for time? Just like period, capital letter T. Dimensions are in capital letter, but the T has a power N. Now, let's go further. You can see that we only have L and T on the right. There's L here, there's L here, there's T here. Before then, let us open this bracket. This is K. You will understand it now if you work it more. Now, there is power M outside. The indices I mentioned, this L will have that power M. L to the power M. This t has a natural power of -2 before. The -2 will multiply that m outside, become -2m. And then there's one t standing alone with power n. Okay, now this is L equals to that. And then L equals to, again, constant. I'll repeat everything. L to the power m. Now there are two t. There's this t here, there's this t here. One has power -2m. The other one has power n. Indices says so long as there's when they are written together, means multiplication sign is between them. We add them together. What is the first? Write a single t, not write the two t again. T. What's the first power? -2m. This multiplication sign from this say we should add them together, plus what is power of the second one? N. Okay, you are getting it now, I believe. Now there is L here and then there is T here. So I'm going to write it. So I'm going to ignore that M. I don't need M. If M is present here, I'll write it. So let me write okay, for okay. Okay, the which one? The K, which part you don't understand, please, again. Oh, sorry, there's equality sign. I was one that made mistake. There's equality sign here. Maybe that is what you are referring to. Let me clean all this. Okay. Yes, this is K. I'm supposed to put equality sign here. Does this attend to what you are saying? There's equality sign there. This is this L here. I made mistake. I ignored the equality sign. Now there is L and T here. Here I'm going to write M, even though M is not present. But so long as it does not exist here, just put power 0. Sometimes you ignore it if it does not if it's not present. Now there is L and T here. Let me write L first. L exists. Now I'm going to write it as well. The C. But C does not exist on the left hand side, so I put power 0. In the end, it is only L that is like here. So long as I put power 0 for M and T, this I have not changed anything. The only thing present here, as you are saying like this, is like just ordinary L is present there. So equals to K, okay, L to the power M, and then T to the power -2M plus N. Now we are going to be comparing coefficients. M does not even exist here at all. So let me just leave M. Okay, I want to start with L. L exists on both sides. So I'm comparing for L now. I'm comparing for L. Now, what is the power of L on the left-hand side? You can see that it is 1. So I'm going to write 1. Then equality sign. What is the power of L on this side? It is just M. That one has even solved the problem. 1 equals to M. So I found M already. So M equals to 1. Automatically, M equals to 1. There's nothing to solve. M equals to 1. Then comparing for the left hand for T. I want to compare for T. What's the power of T here? It is 0. This is 0 here. Equals to, what is the power of T here? As you can see, it is -2M plus N. -2M. Sorry. -2M plus N. Most of you can solve the remaining equation from here like this. Solve the remaining equation. -2M plus N. We have found M to be equals to 1. Just plug it in. So this is going to be 0 equals to -2. M is 1 multiplied by 1. Okay, plus N. 2 times 1 is 2. So 0 equals to -2 plus N. Okay, take this -2 to the other side. It's going to be N equals to +2. Okay, N equals to minus 2 goes to the other side, they become positive 2. So n equals to 2, m equals to 1. So I'll go back to the equation again, the one that have equality sign and constant, not the first one that I wrote here, but this second one that have powers and equality sign after I've introduced k. So s equals to k, a to the power m, t to the power n. S equals to a constant, okay, a to the power m, and then t to the power n. So what is s? S equals to, sorry, who is messaging me? I'm going to see that later. S equals to constant. Acceleration to the power 1. I may leave the power without writing it. If you don't write anything there, it means power 1. Then time to the power 2. Constant. Are you familiar with this equation? Equation of motion. S equals to, let me write it fully. You see it now. Ut plus half a t squared. Now, remember the equation said determine it's asking you, it's telling you that the particle starts its motion from rest. You remember? You say assuming that the distance covered by a particle, which is s, which starts its journey at rest. For the fact that the particle starts its journey at rest, this u means initial velocity, it means 0. When the particle starts from rest, means its initial velocity is 0. So if u is 0, 0 times anything relegates this, everything becomes 0. So the equation becomes s equals to 1 all over 2 a t squared. 1 all over 2 a t squared, because it starts from rest. 1 over 2 is s equals to k a t to the power 2. You will not be told to find the value of the constant. Just leave it like that. You have shown that yes, s actually depends on a and t in this format for a particle that starts a journey from rest. The distance covered is s equals to k a t squared. The distance covered is half a t squared for a particle that starts its motion with initial velocity of 0. If the initial velocity is not 0, the equation becomes s equals to ut plus half a t squared. I told you the constant is not needed. They'll mark this final stage for you. Okay. The first stage they'll mark it. The second stage they mark it. The middle part, they just want to see your indices knowledge of solving how to find the two powers m and n. They'll give you mark for that. If you like, use long step. It's because of explanation. If I'm doing this, your work now, like my own days, we have more papers. we have question on a separate paper and answer booklet on a separate paper. But I think NECO is still using that format. But what you're doing now is they give you small space. So you will know how to manage your step for your indices. There's something that I'm not supposed to do, but because I'm tutoring, I have to explain all those parts. That's why it looks lengthy. Okay, so I think what's the time? Let's look more and more, but this time around, you guys will be, yes. Go ahead. Yes, I'm with you. You are the one that you must give them power. In the end, your indices that you are going to solve will determine whether they even have powers or not. It is the indices that will now show the power. It is you're solving that method that you have solution is now. Sometimes if the power is 1 1, it will just be k equals to 80. K equals to 80. We can look at one that have I want a technical one again to explain further. This one on wave. Let me one equation on the wave. the speed, the speed symbolize V. The speed V. That's why that's there. The speed of sound wave in a stretched string depends on tension in the string. Yes. Sorry, let me see if I'm still sharing screen because it's still showing me that I'm still. I think it's if your data is going off, sometimes it's shield off major thing. The major thing of this class is the screen itself. If maybe you have lower data, I'm still sharing. It's showing me that I'm still sharing. So I don't know who is that, please. I'm still sharing anyway. I'm still sharing. Maybe okay, okay. Maybe you can try to exit and coming back, or you just quickly try to subscribe. The speed of sound wave depends of a stretch string depends on the tension in the string. Okay, depends on T. Remember that I'm saying T is actually a force. I'm going to the power. Use A and this down. Don't just write them. Press on power A. Sorry. This one. T to the power A. And then mu. This is actually the symbol for mu. Something that looks like this. The quotient of friction. Okay, and then power B. Okay, I give them power. So the next thing I'm going to write equality. V equals to a constant K. And then tension is a force. Do not forget, even though we are using tension to represent T, that's not dimension here to the power A. And then mu to the power B. The third line, they'll mark this because you introduce equality and constant. The third stage is you want to put dimension now. Now, what is speed? Speed and velocity. Velocity is what? LT to the power minus 1. So I'm going to write that here. In space of this V, the next stage is to write the dimension of all of them now. So the dimension for velocity is LT minus 1. Acceleration LT minus 2 equals to a constant. Now, tension is a force. Let me write that here. Force is MA. F equals to MA. If I don't know the dimension for force, I know the definition, mass times acceleration. So the dimension for force will go like this. What is the dimension of the first M you see here is capital letter M. Tension is a force, so this T is actually a force. That's what I'm going to now. Acceleration is, look at this LT minus 1. It's going to be, acceleration is LT minus 2. You can see. If you know the definition of quantity, you can write the dimension. So in place of this T, which is a force, a tension force, I'll open a bracket. If it contains more than one letter, the dimension, so I'll open a bracket and then write all the dimension, then now write the power outside the bracket. Okay, now this is M. We are working on one that have M this time around. M L T minus 2. Close it. There's a power A outside. I'm putting it outside here. Now mu. What is mu? They said, go to the question again. The speed of sound wave in a stretched string depends on tension. Tension is a force. We have dealt with that. And the second one, mass per unit length. The symbol is mu. They're giving you the definition. They give you tension. And tension is a force. What is force? The definition of force is mass times acceleration. The definition of this mu is present in the question. Mass per unit. What is per? Divided by mass over length. Mass over length. They've told you it's like velocity. So mu, open bracket, multiplied by mass per unit length. That is mass over mass. This is meaning mass over length. That is the meaning. Mass over length. So what is the dimension for mass above? This mass per this meaning of mass per unit length. It's like density, mass per unit volume. It's like mass over volume. So the dimension for density is going to be, what is the definition? Mass per unit volume. So dimension for mass divided by the dimension for volume. Dimension for mass is capital letter M over dimension of volume is L times L times L, which is L to the power 3. So it's like M divided by L raised to the power 3. The L to the power 3, you can bring it up, becomes M L to the power minus 3. That is density. But this one is just mass over length, because it's a mass per unit length. Mass per unit length, not mass per area. If it is mass per area, what is area? Length times length. All those breadth, length times height, they are all length. So that's why I'm calling it length times 10. 3 length, that's why length raised to the power 3 for volume. For area, length times breadth, which is something like length times 10, which is length to the power 2. So this one, they only measure one length, mass per length, per unit length. So just mass over length. You want to be M over L. And M over L is ML raised to the power minus 1. M over L is M mass per unit length is mass over length raised to the power minus 1. Then close it. It has a bracket, a power B. I believe all of you can even continue from here by yourself. Okay, now, what's the next thing? Let me leave this right hand side. I want to deal with these indices. I'll combine all. Okay, this is K. Then M will take the power A outside here. It's going to be M to that power A. And then L will also have that power A. T has power minus 2 already. Then minus 2 times A will become minus 2A. Minus 2A. Then let's go to the second one. There's times in between them. So this now M inside the bracket has B outside. So it's going to be M to the power B. Then L has a power of minus 1 before. Then minus 1 times B becomes minus 1B. What's the meaning of 1? Anytime you don't mention 1, just write minus B. Minus 1 times B is minus 1B, which is something like minus B. So this is minus B. How I wish, I'm not happy that, what's her name, Amna, is not even seeing this screen. And she's having challenges already. So this is L. Okay, thank you very much. I believe you are getting it now. Watch at the first video, it will be clear. Okay, thank you very much. Now, what is the next? Before I start comparing the powers, I must make sure that I look at. I'm saying how many L am I saying? This is L here. This is L here. This is M here. This is M here. Only one, so I must combine them to have only one M, and all the powers are on top of that one M. Only one L, all the powers. So I'll use indices now. So this is equals to letter K. Now I can see M. I want to bring these two M together. One is having, okay, let me take my time. I'm supposed to do, this is M to the power A. I want to write them together, multiplied by another M to the power B. Now, there are two L again. One is saying L to the power A. Another one is saying L to the power minus B. You can see these two L's. Now, T is the only one standing alone now. This is 2 to the T to the power minus 2A. Minus 2A. Okay, taking my time. Now, the indices. This is equals to constant. Okay, constant. Now, the M is going to be M to the power A plus B. You are familiar with that. That's indices. M to the power A plus B. Sorry. A. So this is A. Okay, then multiply by then L to the power A. It's also a plus. A plus minus B. You have something like this. A plus. Then the second one is having its own minus B. The two more this can this. When plus and minus meet by multiplication, it's going to be minus A minus B. So it's going to be A minus B. The rule for multiplication is actually plus, but because that one is having minus, that's what changes the plus to minus B. Then T to the power minus 2A. Now let me write this. L T to the power minus 1. Okay. Now let me put M here. So M is not originally present here because it does not exist here originally. I'm going to give it power 0. This one that nothing is written means power 1. Okay, so we now have MLT. Originally, I have what here? L and T, no M. That's why I'm giving that M0. If L does not, anything that does not exist on the left originally, write it there and then put power 0. Power 0 means it is equals to 1. So it's like 1 LT, the same thing as just LT to the power minus 1. So we want to compare coefficient. Let me just tell you what to do from here, because if you're working with y that is giving you space for, you start your equating powers here by the one that have only single letter, because that is anyone that have only single letter on the right hand side. That is the one you can quickly find. You can see M has two power here, A and B. L also have power, two powers, A and B, but T have only one power. So first of all, go and compare for T so that you can find the value for A directly. Then you can now go and substitute in any one of either M or B to find the second letter. So I want to compare coefficient of, I'm starting with T first, not M. Otherwise, we just saw simultaneous equation that is not there. I want to compare the powers of T. So what is the powers of T on the left hand side here? It is minus 1. The power of T here is minus 1, then equals to, what is the power of T here? Minus 2A. Minus, we delete minus first. Minus cancel minus. So it's like here 1 equals to 2A, or 2A equals to 1. So what are you going to do to find A? Divide both sides by 2. Divide this by 2. Divide this by 2. So that A equals to half. You can see this gets away this. So A equals to 1 all over 2. Now, there are two powers, A and B. I found A to be equals to 1 all over 2. M here has power A and B. L also has. So I only use one of them, because I only need both of them contain. So if you want to use M, maybe I'm just going to show you using both of them to show that they will still give me the same thing. So for if I want to use M, compare the powers of M. What's the power of M on the left hand side here? It is 0. So 0 equals to, what's the power of M here? A plus B. Let's write it, A plus B. A plus B. But A is equals to 1 all over 2. So 0 equals to 1 all over 2 plus B. Plus B. You take this one over, you see that B equals 1 all over 2. B equals to, sorry, minus 1 all over 2. B equals to, take this outside, becomes minus 1 all over 2. So A equals to 1 over 2, B equals to minus 1 all over 2. But in case you want to use L, I just want to show you so that you can see that anyone you use is the same. If you want to compare powers of T, I just want to write it. What's the power of T here? Minus 1. The power on top of T here is minus 1. Minus 1 equals to, what is the power of T here? Sorry, no, not T. It's L. Power of L. Sorry. I want to use L. I've used T to find this. I want to compare power of T. I'm not supposed to, I found my A and B. I'm just supposed to move. I just want to show you that it's going to be, if I use the power of L, the power of L here is 1. Here's the 1 here. So 1 on the left hand side equals to, what's power of L here? A minus B. A minus B. Now, so this is 1 equals to, what is A? Already, A will have 1 all over 2 minus B. So take this 1 over 2 to go and meet, it's going to be 1 minus, take this 1 over 2 outside. 1 minus 1 all over 2 equals to, this is minus, having minus, so having minus B. Please, this is your algebra. So what's going to be? What is 1 minus half? It is half. 1 minus 1 over 2 is 1 over 2. Remove half from a full, equals to minus B. So if you make an equation like this, just take the minus to go and make the number. So, or you just say divide both sides. This is like minus 1. Divide both sides by minus 1. I don't want to do that. If you see something like this, if you see minus x equals to 12, the meaning is x equals to minus 12. X equals to minus 12. So if you are gotten to this stage, Minus half equals to b. Just conclude that b, take the minus to go and make the number equals to minus 1 over 2. You can see that is what we have here too. So our interest is a equals to, what is a? A equals to half, b equals to minus half. A equals to half, b equals to minus half. Let me go and copy the one above and then substitute back. Sorry, I'm supposed to scroll up. What's the actual equation? Okay, v equals to k, t to the power a, mu to the power b. T to the power a, mu to the power b. V, velocity, equals to a constant, t to the power a, and then mu to the power b. Now, this is equals to k, t to the power a, which is force, t to the power a. What is a? A is 1 all over 2, 1 all over 2, and then mu to the power minus 1 all over 2. Indices rule will take that one down now. So this is the same thing. I want to write it here. So v equals to k t to the power 1 all over 2 divided by, I'm taking that mu down, the power is not going to be positive. Mu to the power also 1 all over 2, no longer minus 1 over 2 again, because I've taken it down. And what is mean of power 1 over 2? That is square root. So this is like, then I want to combine the two together. So it's like square root of t divided by square root of mu. Combine them. We've seen that before. Square root of t divided by, instead of another set of square root, I see square root of mu. Oh, sorry, it is mu, not n. So I'm going to write it down here so that you write your final conclusion that v equals to a constant, then mu f divided by mu. This is the speed of the wave passing through a stretch strain. Okay, k can change value depending on modes. When we get to, if you have a single, this is the wave is going like this. Okay, if it's single mode, the value of k can change, but the basic or the fundamental frequency is going to look like this. Maybe you will notice that you've seen this equation before. 1 all over 2l, sorry, 1 all over 2l, then square root of force, which I'm using as tension now, divided by mu. Don't know whether you're familiar with this equation. So this is the equation actually. You don't need to find the value of k. That's where we are going to put this to an end. I believe this is understood by everybody now, including